Alright, for this question, what you have to do is, of course, find the value of the test statistic is what we're getting at here. So the claim is that IQ scores are normally distributed with a mean greater than 120. A sample of 22 professors had a mean IQ score of 125 with a standard deviation of 4. Find the value of the test statistic. Alright, so first off, what you need to recognize is that this is going to be a one-tailed test, one-tailed analysis. So what we're claiming is that the IQ scores are greater than 120. Alright, so that means that as you look at a normal distribution, you're trying to find some point, and you're saying they're all greater than, so we're going to focus on just one tail of the distribution. If the question said something like not equal to 120, then you would have a two-tailed, and then you would come over here and you'd say not equal to, and it could be less than or greater than. You'd add a part there, but we're not going to deal with that. That's just for a two-tailed when it says not equal to. Alright. So what we need to do here is find the value of the test statistic, which is basically the z-score. Alright, so let me get my calculator out. Alright, so here's the TI-83 that we're going to use. So you'll click the stat button, and we're going to go over to tests. And in this case, we're going to use a t-test. And the reason we use a t-test is because the sample size is small. Generally, the general rule of thumb I've always used is that if this number, the sample size is less than 30, use a t-test. And I believe that's consistent with your textbook. Alright, so we're going to change the input to stats. We use data, it pulls it off a list if you have a list of data, but we actually have the full stats on it. So the mu naught, the mu that we assume it to be at, is 120. That's this value here. Okay. And now our x bar, our sample mean, is 125. And then our standard deviation of our sample is 4. And then the number of sample size here, the number is 22. And again, now down here, we're trying to prove that it's greater than mu naught, greater than 120. So we switched that to greater than, which makes it do a one-tailed test on the greater than side, and you just hit calculate. And so therefore your test statistic is this t value. T equals 5.863. Alright, so that's where you get the answer, and that's how it's calculated with the calculator. So if you don't have the calculator, the fancy calculator, or maybe this question you really don't need to use it, you can use this formula here to calculate the value of the test statistic. You have to know that it's this formula. You have to know that it's t based again on the sample size. You have to know that 22 means we need to use a t. And so the test statistic, you just plug in those numbers. X bar was 125. That was our sample. The mu, the population mean, was 120. And then we divide that by S, which was 4. Standard deviation here was 4. And then we divide that by the square root of 22, the square root of n. So when you do this math here, you get 5. And since you're dividing by a fraction, right, you have 5 over 4 divided by square root of 22. You can change that to 5. Right, when you divide by a fraction, you multiply by its reciprocal, so 5 times the square root of 22 over 4. And if you use your calculator on that, you also get 5.863. Alright, so if you know the formula, you can use the formula in this case, and it's really not that much more work. But if you do have the TI-83 and you know to use the t-test, then that way is also equivalent. Alright, so you have two options there, and hopefully this will help you understand how that works. Now from this point, most questions don't stop here. They go on and they say, now go find the p-value. For those questions, to continue with this question, generally you'd have to pull out the t-tables and find out the critical value to decide whether this is a meaningful result or not. But for now, that's all they want to know is the test statistics, so we just stop here. Alright.